The first thing we've learned on our journey is to use the web the way it was designed to be used by the first web developer of the world, Mr. Tim Berners-Lee. By the way, such a humble job title compared to all the prophets, rockstars, and ninjas from LinkedIn. And the web as devised by Mr. Tim Berners-Lee is all about resources and representations. So we said, OK, let's look at the front page of our newspaper and let's identify some resources. And we realized that basically every logical unit on the front page can be a resource. And all those resources should have some kind of representation. And we said we're going to use HTML5 as the media type for those resources. And each of those resources is going to have a URL. And those URLs may actually come from one monolithic application or from many separate microservices. And finally, each of the resources should have its own cache control header. And basically, this is like the basis of the technique called segmentation by freshness, where different parts of the page can have different levels of freshness. And the recurring theme of this talk is to make reversible decisions. And very often when people try to design microservices, they obsess about, oh, should it be like a microlibrary or a microservice? And my answer to that is do both. When you design a new service, make sure that it can be included as a library, as a jar or, I don't know, NPM module. But also, let's make sure that the entire thing can actually be served from the embedded web server and be used as a microservice. Now, we have those different resources, and we need to somehow put them together into one coherent unit. So how can we do that? And now I want to tell you about how we approach web integration. And we have like multiple options here. And the first option is to do server-side include. What is it about? So basically, we have this aggregator, this backend component that puts different parts of the page together on the backend and returns everything to the browser as one big response. Another option is to use edge-side include. So basically, we're saying, let's outsource the actual integration process to the proxy server, to something like Varnish or Nginx, and let our infrastructure do the heavy lifting of the web integration, and our backend only returns the recipe how to put different parts of the page together. And there is this standard called ESI, edge-side include, and the most important part of the standard is this XML tag called ESI include. And I really, really like this concept. However, when I do web development on my local machine, I don't want to start something like Varnish or Nginx to see what the entire page looks like. So we decided, OK, let's build server-side include that uses ESI tags. And we basically built this Node.js library that can process ESI tags. And it gets the ESI XML as the input. It processes the whole thing, and it spits out the actual content. So again, it's all about reversible decisions. Now we can move the processing logic, ESI processing logic, between the backend server and the proxy server. The third option that we considered, and we actually implemented, is a client-side include. And what is client-side include about? Basically, we're saying, OK, let's use the browser as the integration platform. Our backend only returns like the core content, and all the optional widgets are actually fetched by the browser. What does it look like in practice? So we return our core content, the article text, the article video, stuff like that. And all the additional widgets are just links. So we return links from the backend. And those are regular anchor tags. And now we have a JavaScript library running in the browser. And this JavaScript library goes through a page. It finds all the links. It fetches the content from the external microservice, and it injects the HTML, but also potentially a CSS and JavaScript from the external web service onto our main page. So what does it look like in practice? Well, if you just have the HTML code of our page, it looks like that. But if you enhance it with JavaScript and CSS, the link for the sports game is actually enhanced with the CSS, and we replace the link with the actual content from the external service. So again, It's all about reversible decisions, and it's all about multi-tracking. We always try many options at the same time to choose the best one and to explore the solution space better. And if only one of the 3 options fails, we always have a fallback to the other 2. Now, you may ask, why don't you guys use a single-page app approach to do the integration of the different components? Single-page apps are all the rage nowadays. However, I think that our context is not the right context for single-page applications. And let me explain why. So when I was learning how to do web development a long time ago, it was always said that, oh, there is this thing called server that renders the HTML. There is this HTML that defines a document structure. Then you have like a CSS that defines the layout, the colors, things like that. And at the end, you sprinkle some JavaScript on the top of it to spice it up, to enhance your page. But it turns out that in this new web development world, everything can be done in JavaScript. And I find it really, really scary. Why do I find this really scary? Well, if you look at the web on the client side, the uncertain web, where people have like millions of different devices, different browsers, different add-ons that may break your code. And if you admit to yourself, well, we're gonna make mistakes. We're humans after all, and we're gonna make mistakes. It turns out that in those circumstances, a failing JavaScript in the browser is no longer some corner case. It's gonna happen. And while HTML and CSS degrade gracefully in the browser, JavaScript doesn't. And that's why I prefer to build the escalators, right? The pages that degrade gracefully. When there's no JavaScript, when there's a power outage, they degrade to regular servers rather than elevators, single-page apps. When the JavaScript breaks, the entire page can stop, actually. And some time ago, we didn't follow this advice, and we used an A/B testing tool that was generating titles on the front page, and there was no fallback to the HTML. And imagine what? Well, at some point, all the titles disappeared because someone made a mistake. And this story only reminds us that progressive enhancement is not dead. Okay? It's still worth to do progressive enhancement. Those are our readers at 8 a.m. in the morning on the tube. And they usually have like a minute or two to see what's going on in the world, to read some news. And most of those users, when they come to our page from mobile devices, if they haven't visited us for some time, they're going to have empty cache in their mobile devices. And what can we do? Well, we can either force them to download like a half of megabyte of JavaScript before they see any content, or we can just return simple HTML, simple CSS, and the actual content, and then load JavaScript asynchronously in the background. But those are not our only users. We have also those less typical users like Mr. Bot, Mr. wget, and Mr. curl. And those guys, they look at the world differently than we do. If you want to see what their world looks like, well, try that. Do view source on any page. And if it happens to be a single-page app, this is what you're going to see. You're going to see some empty HTML container. And you can't read any news. So you want to be nice to Mr. curl and Mr. bot and Mr. wget, and you say, OK, let's generate a separate version of the page just for those programmatic clients. And let's use Phantom.js to build our pre-rendering infrastructure. And then those who've been that way will tell you, don't go that way. Millions of bugs on GitHub, constant crashes in production, very heavy usage of CPU and memory are only some of the few memories of those who've been that way.